未来のパートナーはあなた自身、石川恵理香です。本日はですね、スペシャルなゲスト3名にお越しいただいております。Uaf のカンファレンスの後にこちら撮影をさせていただいているんですけれども、Uaf のエキスパートの皆様です。私より素晴らしい、知見を持っていらっしゃるので、Uaf は何なのか、また Uaf がなぜ日本に必要なのか、そういった点についてお聞きをしていきたいと思います。So, hello everybody.
Hello, Erica.
Would you introduce yourself very quickly? Starting from you.
Hello. I am Matthew Hawes. I work for SSI. I'm the INCOSI representative at the UAF.
I'm Laura Hart. I work for Lockheed Martin, and I also am a co-chair of the UAF Revision Task Force.
Hello, my name is Aurelius Morkevicius. I represent the SAW system, and I'm a co-chair of UAF together with Matthew and Laura.
Thank you so much. So the first question I would like to ask is, what is UAF and who is using it in the United States and globally?
The UAF is a modeling language, and you can use it for describing what are called enterprise architectures, systems of systems, and also what are known as family of systems. Basically, if you have a complex organization and you want to model what is the organization made up of, what are they trying to accomplish, and then eventually how do they accomplish it. But its main benefit is it separates the what are you trying to accomplish from how do you do so. And people are using this largely in the military space, but also in many civilian areas as well.
So why Japan should use this UAF, and what is its importance towards Japanese market?
Well, the UAF framework is a standard, and using these standards will help interoperability between different organizations. So, for example, if your military service groups are kind of siloed, if they use something like UAF, which has well-defined semantics for all the various concepts that you might want to capture, if they can use that to capture their enterprise architectures, at some point you can start federating across these different enterprise architectures to start communicating more precisely using terms that have well-defined meanings.
Well, maybe also adding to that is it really, because you apply UAF for many purposes. It's Unified Architecture Framework, and Unified stands for many things like mission engineering, enterprise engineering, or system engineering. So, for example, one of the recent use cases is really, digital transformation planning. So this is where you can define what is your current portfolio of systems and how you want to transform your current portfolio of systems to the future portfolio of systems. And UAF is a perfect tool to do that.
So one of the other reasons why, or one of the other benefits of using it is that we're using is in model-based acquisition. And model-based acquisition is really about using good systems engineering as well as UAF to communicate what the government might actually need, and then to be able to communicate that precisely using UAF to the suppliers, and then giving some guidance on how the suppliers would respond back in kind with a model. If you don't have that definition on both sides, let's just say that you could get multiple proposals from various suppliers, and then each one of those you'd have to go and figure out, did they give me the information I needed to actually evaluate their proposals? And by creating these standards using things like UAF that has precise definitions for these concepts, it just makes it a lot more interoperable. And one of the things that we probably haven't discussed is that just in general how UAF is organized across these various levels like strategic, and I think Matthew is going to speak a little bit about that, but we cover a lot of different kinds of concepts to address different ways of using UAF.
Yeah, the UAF works, it has multiple viewpoints. So in other words, the people who are strategic viewers or the decision makers or the implementers, etc., all have their means of entering their information, but also seeing reports. But all of this is written into the same database. So the people who are trying to do the planning can say, this is what I would like to be able to do. And then the people who are going to show how you will implement this can build their solutions in the same model. Then the decision makers can do analysis on this and decide, okay, does the implementation fit with the capabilities we are trying to implement? So rather than having different views or having to move the information from one place to another, it allows all of them to work together on the same database.
Well, thank you so much. So I think the digital transformation implementation was mentioned, and I have been doing the digital transformation consulting for years. And, the companies in Japan, they're struggling to unify all their operations, and they're blind to come up with a purpose and strategic view, business model as a whole. So I think Uaf would be very beneficial to that point. And my next question is, who in Japan should be using the Uaf and why? Sector-wise, size of the companies, and who would be the best suitable enterprise that's going to be using the Uaf in Japan.
One of the things to also consider is your institutional knowledge and how you can use Uaf to capture not just your technical institutional knowledge, but your strategic drivers and what you're really trying to achieve. And often, we undervalue that, but to be able to capture that over, especially for long-lived programs that might live 15, 20 years, to understand the drivers of why those programs were built the way they are. That's very important information.
So, actually, what industries and what companies should use it? I would probably say it can be used in any industry and by any company. But really, as a model-based approach, at the end is about maturity of organization. And what we see today, of course, the primary industry is aerospace and defense. It's just because of mature system engineering practices that they have. Automotive maybe is probably ranked second because they are also going into more model-based approach. And again, we're still speaking about more engineering discipline. But other companies, we also see some uses in gas and oil industry or energy. We see some uses in infrastructure. Smart cities is very hot topic in recent days. Agriculture, because it's really about sustainability, about smart and sustainable farming. So there's really, different industries can do it. Maybe if we speak more about banking or insurance, I think we could definitely use it, but there is a little bit of immature, let's say, practices of doing enterprise architectures today, more focused on PowerPoint documents. And I think it will take time until, these industries can really go into more precise model-based approach as Uaf is.
Do you think it's also because, where we think the value is, or the groups that see the value are the ones that they have these very large interconnected systems where there's a lot of complexity and interaction. When you talk about the government and the interaction, you talk about how long these programs live, and that institutional knowledge needs to be captured. And, so it's a different kind of system right now that's using it, but there's probably value to the other systems as well, but more so to these systems as systems that you're trying to capture. And as far as some of the issues to adopt this is that it does not come for free. You do need to have training and invest in not just using the tools, but training the people on the systems engineering discipline first, and then the models to capture the information.
And largely it depends on where you are. And for instance, in Sweden, the Swedish military is using this to figure out how are they going to plan their defense industry. But we have also used it at Volvo to model how would we do an electric quarry and see the different performance characteristics also on a electric road, because they're trying to become greener and greener. As Aurelius mentioned, oil and gas. I worked on a project in Australia where they were trying to model a gas extraction system, which is called coal seam gas, which they have to extract the water from it and transport it 1,000 miles. And it's a very complex system of systems. And they found the only way they could express this was with UAF. Also, their mass transit systems, and they use the UAF to model their entire defense capabilities structure. Other places in Brazil, so it was used in aircraft industry, and in North America, largely the military operations. But in the U.S. military, specifically, any large program has to have DODAP. So for understanding between the different branches, and it's because the U.S. government wants to understand and have control and make sure people think before they start building. And this is the main benefit of UAF.
Do you want to say anything about our original goals of collaborating across, like with NATO?
Oh, yes. Because, of course, one of the reasons we started this 17 years ago, and the main purpose was semantic interoperability across the nations. One of the biggest problems, there was a paper on the Afghanistan war, the very first one, where they said everyone had an architecture, but no one understood anyone else's architecture because it had different terminologies. No one could do any interchange. And from their point of view, it cost time and money and possibly lives because of the lack of interoperability between the architectures. So the governments from many countries in NATO, as well as Sweden, Australia, and others, worked together to create this UPDM and the Ideas Foundation, because they said, if we're going to cooperate, we must be able to communicate. And if we're going to communicate, we need a common language. And this was UAF.
And just so that was our goal, but you have to start small. So right now we're looking at, that interoperability across our different services. You could do the same thing, but eventually it would be across nations. I don't think we've realized that yet, but that was our goal. And if you look at the UAF specification, we call them donor frameworks. We have the NAF donor framework. We have the MODAF, Ministry of Defense framework. We have the DODAF framework. And we try to kind of normalize across all the various concepts. And that's that semantic agreement we have.
Well, thank you so much. It sounds like, it can be used in many sectors, any industries. But my question is, above 90% of Japanese companies are SMEs, small and medium enterprise companies. Do you see any chance or any benefit for SMEs to using UAF?
Laura was talking about where the government says, we want you to provide this system, so they give them a model. I have worked in projects where there is a model which people have to integrate their submodels into, where you actually had integrated models across the sector. One of these major areas is in automotive, especially in Germany. Another area was in the UK, where I was working on a military project, and there were many different suppliers, and they all had to integrate their models into a larger one. So yes, these small groups do have to often integrate.
So instead of thinking about the government acquiring a system from the suppliers, just think of acquirers in general needing to integrate across multiple suppliers, and that would be your case.
I would mention, in addition to Matthew, I would mention a couple of projects in Europe we're currently having in the defense industry, the UK, Italy, and Sweden, and also Afghan, France, Germany, and Spain. And this is where it's kind of good example where we have multiple contractors involved, some even actually trace to Japan. There are some companies in Japan involved into supplying some of the components to project. And there are certain requirements within both programs that NATO architecture framework would be used, and it's based on the Unified Architecture Framework language. In these examples, we see really smaller companies involved as well, not only the first year contractors, but also the second year or even the third year contractors really working on it and collaborating between different suppliers involved.
Well, that's great to hear because, as I said, more than 90% are SABs in Japan. So, now that we have some ideas, what is UAF and which industries and sectors are using it and how we can benefit from UAF. And the next question, the audience is wondering how much would it cost? Because, when I talk to the CEOs, CTOs, they always, ask me this question, what is ROI? What is the cost associated? And I think Laura just mentioned about the training cost. It's not just a tool cost, but how much would that cost, like roughly, if you were to start? I understand it depends on the project per project, but they don't know any idea of UAF. So if you could, give us some estimate numbers, that would be great.
How do you currently train your systems engineering workforce?
It depends on the project per project, but the training cost would be around 20,000 to 50,000 for a week of training, I think.
It sounds like you typically get your training from an external source. So that would be the difference. So in some of our large corporations, we develop our own internal training, especially if we're going to be training hundreds of people or thousands of people. So that would change it as well. So I think it would probably be similar to how you would teach SysML. It's not just about using the tools and modeling. It's about, a process and an approach.
I think in general, good architecture is really expensive at the beginning. We will not lie to you because, training, what we discussed, tools are expensive. Then depends on what kind of tools you use. Because if you don't invest in the proper tools, then, you may not really achieve certain goals. The training is the same story. You need quality in the training. You want good people to work on it, right? Who are capable. So it's really expensive, but at the end, it really pays off. So it may be, like a steep expense curve at the beginning, but at the end, you will definitely see some results.
And also, it's something that you build on. You've got to get that foundation down first. So if you're going to deploy this at an enterprise level, you pilot, you adjust, you make sure that you're growing the pipeline of people that can teach the rest of you don't want a bottleneck for your training. This is where you find you decide you can have two experts and they're going to do everything. This is not going to scale well. But start with the fundamentals, good systems engineering, good architecture, using the tools correctly, getting trained properly. If you think that you can just take a UAF tool and fill out the templates, you are not going to reap the benefit. And like Aurelius is saying, if you invest in this architecture, this institutional knowledge that you're building up, it will serve you well downstream, but there is a cost up front.
And there is a learning curve. I used to sell these tools and would always say that the first project you use them on will cost more. It just must. If you change the language that everyone in the project is going to speak, it will take them a while to be able to communicate effectively. I think many people in Japan are probably learning English, and at first it takes a while to be able to communicate effectively, but you will figure it out after a while, and then everyone can communicate effectively. But it takes time to learn these new thinking concepts, because it's not just understanding vocabulary, it's understanding the systems engineering methodology and the architecting, which takes the real time. And this is why Laura was saying you need people who can do the training. You also need people on the project who are experts in this, because everyone will do it wrong the first few times. And if you have someone who can guide them into the right way to do this, it will save time. There is no substitute for someone who is on the project, who knows how to do this quickly and effectively, and to make sure the project is working well together. In other words, that you're communicating effectively in UAF. So it's also, one final thing is, there are different levels of training that you will need. There will be people who will just simply be a decision maker, and they will look at the decision-making views of UAF. Other people's will be contributors. In other words, they don't need to know how to model, but they need to be able to communicate and read the diagrams. And finally, you have the experts who are building. And there are different levels of training for each. And you can save time by making sure that you effectively have the right levels of training for the different types of people who are using.
So we've seen that the kind of a process just-in-time training for a program that wanted to go model-based, right? You give them all this training, and the training is, multidimensional. It's the process or methodology, it's the language itself, and it's the tool that you use. You need all of those. And we give that training and we get them started. You also need someone that is going to stay with that program, because what will happen is the first time that that program runs into any type of pushback or crisis, something that feels uncomfortable, they will revert back. So you need to have someone monitoring them and identify who is going to be that person that's going to be the expert when the first expert's gone. So it's always train the trainer as well. So that's some of the things we've learned, is that you don't just do train and leave them alone. You do training, mentoring, and then you train someone else to take your place. And that's a good long-term strategy.
So I think the training would be the highest cost.
Gaining experience, yes.
So how long usually would it take to train a person? I think, Matthew, you have the training course. How long is a training course?
The model I've been using recently is, we used to teach all of UAF in a week, and it's very hard because the concepts are so new. And we found that if you do just half a day every day over 2 weeks, that it gives people a chance to think about things overnight. You can give them some exercises to do in the evening, and it allows them more time. Or you can take a university approach where you just simply have a couple of lessons every week, again, over many weeks. You can do it in a crash course within a week, as long as they're immediately using it and you're working with them on the project to make sure that things go along. But there is that understanding curve where you will use all the different tools incorrectly, and you won't be able to understand the difference between a capability, between a solution-independent activity, between an implementation activity and a service. And having someone there who can quickly correct these things and help you to understand the concepts helps. So largely it depends on how quickly people will use them, and also the level of experience of the engineers.
From my point of view as a tool vendor, is really, we usually try to focus on, first of all, training the language, training also, how to use the tool. So that would be probably 4 or 5 day training. But then, you have to practice it after the training, because if you don't practice it, you actually get it. You're gonna need another training. So we try to work on some proof of concept project with the customer, at least, for some time, where client would build the model. There is no value if we build the model. The client needs to build the model. And then we can collaborate on the model, and we can advise, maybe set up some workshops afterwards. It's usually a longer process than just simply providing the training. And in most of the cases, there are also third party involved, consultants like Matthew, for example, who actually continues working with the customer.
Now think about just a software development class. Someone takes a C++ class. They know the language. They know how to create a program. But how good are they? Practice and experience does account for a lot. We can speed that up with mentoring. So it's not just training. I think what we're saying, we also need mentoring for some period of time to keep them, to kind of guide them when they run into something that is unexpected, and just kind of do it a gentle correction.
Sometimes with the large companies and more like enterprise scale adoption, we really want to practice train the trainer approach, so that the competence is within the company. So we train a couple of people who would be driving the program, and then having knowledge, they would actually train and help the others in the company.
And that's what I was saying earlier about train the trainer. So you take that train the trainer one more level, and that would be on a large program. You would take one of those trainers and you would train someone that would be dedicated to that program. So that, is scalable.
And the final point is that you can have the training, you can have the tools, but you must be a good systems engineer. In other words, if I were to go to my hardware store and buy all the best tools and then try to build a house, it would be a very bad house because I am not a good carpenter. So if I am a good carpenter and then go from using hand tools to electric tools to be more efficient to do this, then I will have the skills already to do this properly. So you have to do both things at once. In other words, there is the expertise for building systems, there is the tools for building systems, understanding systems and architecture concepts, and they all go together. The tool will not make you a better systems engineer. It will just help you engineer systems better.
So I would prefer to teach a systems engineer or an architect how to use the modeling tool than to take a modeler and try to teach them all the discipline of systems engineering and architecting. Both SE and the architecture is the discipline. The modeling is a tool that is used by the SE and the architect to communicate and manage their data.
Well, thank you so much. It sounds like a very long journey, but it's worth it, right?
It is.
Okay. So my next question is, can you share us any success stories? I'm sure, most of the use cases are classified, but if you could probably briefly mention about the success stories.
There is one actually that is published because, as you say, it's many of them are classified. But also the other thing is that really, even if they're not, no one really puts the effort to put it in a paper or the presentation and share it. But there is one that's published as in Cozy paper that comes from Lockheed Martin and Steve Mitchell and the team. It's interesting that there are like two publications. One is done in 2009, I believe, where they just described, what they plan to do. It's a rough plan on the submarine kind of upgrade system. I'm not a very big expert on that, but what they wanted to do is to upgrade the U.S. submarine fleet, where the submarines are different from the different year and different shape and different systems. And now they have to manage the common update on the sonars, on the radios, on the weaponry. And it's of course very complicated because the fleet is a lot of variants of submarines, and to handle that they needed to do a model-based approach, which involved both the SysML for the system engineering and Uaf for a higher level and system of system and communication with the government as well. And so in 2009, they described really what they want to achieve. And in 2018, they described what they achieved with the very precise numbers. I don't remember numbers now, but this is publicly available publication. So anyone can actually go, and maybe I can send you the link afterwards, and actually check those numbers by themselves. But they are actually really impressive. because they compared of how much money they saved because of the model-based approach compared to if they would do like a document-based approach.
Okay, thank you so much. So that's all the questions I had. Lastly, if you have any message to our Japanese audience, that'd be great, because we touched upon what is UAF and the benefit of it, and the cost associated is very high. So I think Japanese audience is very scared at this point. So if you could somehow encourage them to pursue UAF implementations, that'd be great.
Uaf is very large language. It covers a lot of different concepts, but you don't have to use all of it. And that's the message, is that you can start small. And you don't have to embrace all of it.
Think big, start small, and evolve, right? That's something what we used to say. But also, I would like to add that people always afraid of something new. They don't want to change. And of course, this is probably everywhere in every industry. They're used to the old practices, but in many industries, you need something to happen for them to switch into more precise really approach. And we've seen that in automotive with electrification and autonomous driving. So these are really two big changes that happened in probably 10 years, 5 years. And now we see automotive really moving towards model-based, just because they're no longer able to handle these two novelties with just using documents. They need model-based approach. And it's the same, I think, in other industries, and it's moving, it's getting there step by step. And if we have, more consultants, even in Japanese, like more consulting firms starting to pick up on UAF and bring this in front of the different clients, this can actually speed up the evolution and the deployment of UAF and other model-based approaches. So I think it's really nothing to be afraid of. It's a big opportunity.
So maybe something else that's going to help in the future is that we're starting to look more for patterns of reuse. And I think that's going to help people adopt model-based systems engineering in general. Things like reference architectures, reusable patterns, and the concept of MOSA, which is Modular Open System Approach. I think we're going to start seeing more defined reusable patterns, and we're also aware of the fact that we need to start providing better guidance on how to use those patterns, and maybe that will help the adoption.
And to drive home what Aurelius said, he is right. Start small, think big, and increment this slowly over time. If you wish to fail, you should try to adopt all of UAF immediately and draw all of the diagrams and model as much as possible, because you will just keep modeling until the end of time. It's have a plan, figure out what are the different things you wish to do. And for every model, why am I building the model? What is its purpose? Who will read it? For every diagram you draw, what is the purpose of the diagram? What are the questions I wish to answer? And how will it do so? Also, implement UAF where you are having the most problems. Where are you having trouble communicating? And largely you'll find this is in interfaces. As Laura said, it's how do you keep the silos from maintaining their silos? How do you get the different parts to communicate to one another? And this is where UAF can help. If you build your models initially just simply showing where these systems fit together, you will immediately find benefit. And then you can add information as time goes on.
One of the things you don't want to do, and this is what I see with like new adopters, is they get this tool, and like Matthew said, they start modeling, and they don't know what to put in the model. So they put the things they know the best, which is not the problem areas. So they go really deep in capturing so much information of something that they already know. And they put aside the hard problem, the things that are at risk, and that's where they should be putting their time. And also, if they don't know what to put in the model, sometimes they'll just put as much information about something that they know. So be very selective about what you put in the model. Understand why you're putting in the model and how you're going to use it. I think that is like a key thing to keep in mind when you're starting out on this journey.
I just wanted to add that we here in OMG, what we do and what Matthew said, like for 15 years, is really interact with our clients, interact with industries, government, academia, get their needs. We're basically doing systems engineering here.
Yeah.
Where we get their needs, we analyze them, we put them into the standard, we release the standard, and we maintain it. Yeah. So it's really, also if you're using Uaf already, you can become part of the family. You can, provide us feedback. We can address your needs. The standard can become better. And, it's kind of never an incrementing cycle.
Yes, that's how that's how the Uaf has grown, is because we'll have a supplier come in and say, well, we really need to have the personnel view, or what, we really need to capture that strategic view. So if there's something that's missing in the standard or you don't like, if you're part of the OMG, you have a vote and on how it's going to go in the future, including providing guidance on how to use it.
皆様いかがだったでしょうか。Uaf の本当にトップランナーの、お三方に、インタビューをさせていただいたんですけれども、Uaf のメリットについて少しだけイメージを、持っていただけたかと、存じます。ただですね、この Uaf なんですけれども、3人の方15年間やられているというお話があったと思います。これはですね、日本がどれだけ遅れているのかということが、現れている証拠なのかなとも思います。なので、日本というのは、DX で言うと28位ですよね。国で言うと。ものすごく遅れている、国なんですね。で、Uaf が15年、もっと前ですけれども、そこからずっと、アメリカであるとか、イギリスとかですね、欧米諸国で使われていたのに、日本ではまだ全然使われていないと。で、これはもう避けられないことなんですよね。なので、今後どんどんとですね、私も政府であるとか、名前は出せないですけれども、いろいろなところで Uaf を布教しているので、そういった波がですね、押し寄せてきたときに手遅れにならないように、ぜひですね、Uaf に挑戦をしていただければというふうに存じます。はい。So, thank you so much for your valuable time, and it was very educating. Thank you.
And thank you to the Japanese market for their interest.
Thank you so much.
Thank you. Arigato.